DNA repair.
Uh-huh.
So the second one that you mentioned, the DNA like repair polymerases or proteins, whatever you call them.
Mismatch repair?
Mismatch repair.
Okay, yes.
In the slide it says that it uses DNA polymerase to close the gaps. But how does that make sense?
It uses it uses DNA repair polymerase.
Oh, so it's not
There's-
the same as DNA.
It's not the same. The main DNA polymerase likes to go long. DNA repair polymerase likes to go short.
Okay. And then also, just like a distinction between DNA polymerase and RNA polymerase. DNA polymerase can go both ways, like both directions.
Let's be careful what we say there. It can polymerize 5' to 3'.
But it can also, it has the ability to go backwards to exo.
It has an exonuclease that goes 3' to 5'.
So RNA polymerase only goes 5' to 3'.
Yes. Yes, sir.
I read in your slide, I can't even tell you where, but I read in your slide it said the direction in which transcription goes determines the gene's encoding. And it always goes 5' to 3', so I don't understand the direction.
Okay. Your DNA is going to have 2 strands.
Okay.
No, go ahead. Go ahead. Go ahead. Go
Okay,
ahead.
do I stop right there? Yeah.
Next question.
Next question. Okay.
No, can you go? Go ahead.
Yes, ma'am.
Are
No,
exonucleases
cannot.
the same thing, or are they specifically different enzymes?
Exonuclease is a subcategory of a nuclease. A nuclease may be an exonuclease that chews on the ends of DNA, or an endonuclease that chews on the middle of DNA.
Basically the same concept though.
Same concept, they both chew DNA, it's just where they chew. An exo says it's at the end, endo in the middle.
So what did we talk about today? Restriction? Endonuclease. So restriction is on, is there cutting?
I didn't talk about any endo. Yes, sir.
Are eukaryotes both multicistronic and monocistronic? Because there's a eukaryotic polyribosome.
Okay. No. A eukaryotic organism does not have polycistronic messages. It may have a polyribosome where multiple ribosomes bind the same message in the cytoplasm. Are we good there? Okay.
Are poly and multicistronic the same?
Yeah.
Okay.
Yes. Yeah, it depends on which book you look in, which text you look in.
Could you help? Can you help me understand exactly like the very last? I guess it's the last thing that you talked about is like the different kinds of hairpins and things
All
like
that stuff at the end? Okay. There's like 4 figures there. All that is an example of post-transcriptional regulation. That's it. Generally in prokaryotes, transcription and translation are coupled. But every once in a while it's not. And the message, the mRNA, can fold different ways. And if it folds in different ways, it may cover up the Scheindelgarno, it may cover up the AUG, it may do numerous things. But when it does this, it can block or enhance expression. Then in response to the environment, simple case that we showed there is temperature. All that base pairing is subject to temperature changes. You raise the temperature a little, it opens up and allows the ribosome to bind to the AUG. That make sense? Those are all different examples of stuff that could happen.
And what exactly do you mean by, I know post-translational or post-transcriptional modification, but you're saying, because usually
Not
it's tied-
modification, regulation. Because it's after transcription. Modification means something else. It's post-transcriptional regulation. The transcript is completely made. It's hanging out, it's floating around in the cytoplasm of the cell.
And you're saying usually that wouldn't happen because usually
It's generally coupled, transcription and translation. But in this case, these transcripts that are produced are not transcribed immediately. It folds, it makes hairpins, and those hairpins will regulate the translation of the message. Yes?
When we talked about that in class, you talked about how sometimes that one ribosome may go through and translate it, and then sometimes it may come back and it will change it. Like if the post-transcription, like we had the hairpin, and then we had something bind to it, and you said sometimes this thing will come in and bind it and block it for a second like translation. So does it go through several times and translate the?
Each message is going to be different.
Okay.
And each message, the formation is dynamic.
Right.
It may form, it may break, it may get translated, it may hang out. All these things are a dynamic situation in response to their environment. Yes, sir?
Did you say all nucleases were 3' to 5'?
No,
No.
didn't say that.
So then what would,
The,
and
the nuclease that we talked about on RNA polymerase is 3' to 5'. Other nucleases, particularly endonucleases, chew in the middle. They may make a 5' overhang, they may make a 3' overhang.